Hi, I'm Stuart Fieser with Alta 3 Research. Welcome to a short presentation on Asterisk architecture, and by example we'll show you how to place a call through the Asterisk system. Specifically, we will take a look at how to configure a SIP phone and bind it to a SIP channel as part of the Asterisk channel module, the SIP channel module. We will configure the channel module to direct the call inward to the dial plan context, which will map the call actually to another context and then back out to a SIP channel onward to the phone. So the basic concept regarding tracking a call through Asterisk is to begin with a phone, the next step a channel, which is really the only way in or out of Asterisk is through some sort of channel using some industry standard protocol like SIP in this case. The next step, which is mandatory by the way, is to direct the call to the dial plan. Notice the dial plan is right in the center. This is where the actual switching logic occurs, where the dial plan is going to direct the call back out to a SIP channel, where the SIP channel, because of earlier registration, is able to direct the call to the SIP phone. So we see these 5 steps involved here, where, by the way, I'm showing 3A and 3B. I don't think they deserve to be steps 3 and 4, for instance, because this is happening inside the context. The main components that I think you should be aware of before we dig any deeper would be to recognize the phone, a channel, which is the software logic or the protocol conversion, in this case from SIP to an Asterisk proprietary protocol. But no switching takes place, just protocol conversion, where the SIP traffic, now Asterisk proprietary, sent to the dial plan, where the call routing decision must be made. If you have an IP background, you would say that your router would have a routing table. But in the world of telephone, they don't have routing tables. Telephone people have dial plans. So this is the routing table, if you will, for routing a call, which we are going to configure to send the call back out to the appropriate SIP channel. So this channel number 4 right here is actually referred to by 2 separate components. SIP, which is the arbitrary name that Asterisk chose to name this particular software module, and then a slash, and then the channel ID. I'm going to make it simple, and I'm going to call this channel ID 2002. And the channel ID for this number 2 up here, I'm going to make it 2001. Bear in mind that call flow does not have to be restricted to just SIP. There's a lot of other software modules that can be included or loaded to open up an IAX channel, for instance. This is where we would connect to another Asterisk box using the Inter-Asterisk Exchange protocol. Maybe H323 or Media Gateway Control Protocol, the Cisco Celsius Call Control Protocol, or Unistim. The Nortel guys, for instance, would be examples of different modules that people have written and contributed to the Asterisk project. On the outside, each one of these software modules is industry standard, and the name of the module tells all. But facing inward, it's Asterisk proprietary. And we don't really study that because it's not really important unless, of course, it would be your intention to write a new module to take some sort of new protocol from the outside and map it into the dial plan, where one of the motivations of this would be that you have some new protocol that you want to map into the dial plan, because once you're in the dial plan you can go back out any one of these channels, having Asterisk do protocol modification for you, and that in itself can be kind of convenient. Now we are going to restrict our discussion to these components, which I think are the most important to understand Asterisk architecture, but it doesn't necessarily restrict to just routing a call, for instance, to 2002. Maybe the call goes from 2001 to voicemail, in which case we would go to an Asterisk application. So the discussion of Asterisk applications, which would be internal to the box, we'll leave that for another time. Another thing for another time would be the discussion of the media. So if we are going to play back pre-recorded WAV files or GSM files, or if we're going to do real-time conversion, where, by the way, you notice some of these codecs like G729 here are not free. Other ones like the G711 and GSM in some countries, free to use those without having to pay royalties. For the most part, the G711 interface and speaks probably remain the most popular of the free codecs to come in or out of Asterisk. Asterisk by default, though, its favorite codec is GSM. If you load Asterisk, it will prefer to have all of its little files recorded in GSM, able to get a phone call to flow through the Asterisk system. I'll see you in the next video. Bye now. Our first step is to configure the phone to make it match the configuration in the SIP config file. You will find a SIP config file, which is a simple text file, in the directory /etc/asterisk. If you open up this file using whatever your favorite editor is, you will find many channels in there. Unless, of course, it's a blank file and you're getting to configure it for the first time. In my case, I have prepared 3 channels for you to look at, and I've named the channels 2001 inside of square brackets, 2002, and SIP trunk. And they're pretty self-explanatory for what each one of these channels are to be used. Where 2001 and 2002 are host dynamic, because we expect the phone, which obtained an IP address by DHCP, to register and therefore supply these particular channels with the IP address that they happen to have at the moment. But the SIP trunk channel would be an example of a SIP trunk, where the IP address of the device that we're trunking to could be supplied by a fully qualified domain name or just static IP address if you wish. We will take a look at this at a future time as well under the category of SIP trunking. Let's consider ourselves fortunate if we can figure out how to get a call to come in the 2001 channel, pass through the appropriate contexts, and go back out a 2002 channel and ring a phone. So in order to marry up the phone with the SIP channel, the first step is to name the channel. So I named it 2001, and then in the phone, under a user ID, whichever phone you're using, somewhere there will be a user ID entry, and you'll enter 2001. The example that you see right here is taken from a Linksys phone, and I've just carefully made these two match. If they don't match, this isn't going to work. You'll never get a successful registration. And speaking of a successful registration, you also have to match up the passwords. One more thing, the phone is not going to know the IP address of the Asterisk system unless you supply it somewhere. There's a few different ways to do it. The easiest way is to simply type in the IP address, which you see I typed 192.168.200.119. But there are far better ways. If you study the DNS and you use a locating SIP service, or even a fully qualified domain name would be better than typing in the IP address. I'm a big DNS fan, so if it weren't for the fact that I'm trying to keep this simple, I would have clicked yes to both of these, and I would have been using a DNS SRV record, where I would then simply type in the domain name up here, and then I would let the DNS supply the IP address. But these 3 things, 1, 2, 3, are mandatory to get the phone to register to the SIP channel. Now, you're probably, at least I hope you're wondering, well, wait a minute, Stu, I see the channel ID and I see the secret, the password, but where's the IP address? Well, I'm not showing it, but in the SIP config text file, there would be a bind entry that would say bind equals, and then the IP address and port address that the Asterisk system will be listening for SIP traffic. So those 3 things must match. One more thing, however, just to make the discussion complete. The 4th item, you should really configure a dial plan on the phone so that the phone will know when you're finished dialing. So I've given you a real simple dial plan here that if I dial 2 plus 3 digits, and then you see the pipe there, which means OR, and then we see a 9 followed by 10 additional digits, where X means any dialable digit. So if I dial a 2000 number, or if I dial a 9 plus 10 digits, this dial plan will be satisfied, and upon satisfying it, a SIP invite will be sent to the IP address that we have specified on the phone. Where when the inbound invite comes into our SIP channel, the next step is to map it to the appropriate context. Take note in this particular case, if a call comes in to channel 2001 from the IP address of a phone which is registered, you must specify a context. This is used for inbound traffic to the channel. So we have the phone, sent an invite to the SIP channel. The SIP channel will reference a context and send the invite, now using the proprietary Asterisk protocol, into the dial plan. Or if you prefer to see how the flow would be up here, we saw the invite coming in as a SIP message. Then we see the context assignment, which would direct using Asterisk proprietary to context big guy. Now, if we take a look at the configuration of the context big guy, which would be found in extensions.conf file, which is a text file, which, by the way, you would also find in /etc/asterisk. There is a context called big guy. Do not confuse a context with a channel identifier. The context big guy here is found using I admit it's using the square brackets. It sort of looks the same, but it's not. It's called a context in extensions.conf. And within a context must be all the dialed numbers that we expect Asterisk to be able to process. So I made judicious use of include parameter, which I hope you do as well. So my first step is to begin the processing. Now bear in mind we said that 2001 just dialed 2002. So we saw the invite go to the channel module. The channel module sent the invite into big guy, and big guy context begins by looking for the dial digit 2001 in the local context, where we see that the first entry is a little underscore. Now, underscore in Asterisk means what follows me is a pattern. The 9, taken literally as the first digit, must be a 9. The next digit is an N. That's understandable because of that underscore you see. So the N means I am a digit of a value 2 through 9. I will never be a 0 or a 1. The X is I am any digit 0 through 9. So this would be an example of a North American 7-digit number because, believe it or not, some places in America you can still dial 7 digits. But whatever the case, it didn't work out because we dialed 2002, and that is definitely not going to match 2002. So we go back to the big guy. We cross out the include. That didn't work out this time. So we see the next one is include North America. So up we go to North America. That does not match 2002, so right back. And we see the next step is world. So we go up here to the world. No match there, so we come back. And the next step is include internal. Now, if this doesn't match, game over. But it turns out that in the internal context, there is an extend equals 2002. Then we see the little comma and a priority. That must be a 1. You see there's other options. We could make it step 1 would be to try to ring this, and then step 2 would be to go to voicemail, and step 3 and so on if you want. But to keep this nice and simple, you must put the comma, 1 comma in there. That's the priority, followed by a verb, in this case dial, which means connect to. Now hopefully you remember this from a discussion. The SIP, S-I-P, is the name of a channel module, which of course we do have a SIP channel module. And then the slash, which is mandatory, and to the right of the slash must be the name of a channel, which, by the way, we are going to have a 2002 right there. So right here is all the information that the dial plan needs to send this particular call back to the SIP channel and reference channel ID 2002. I'll see you in the next video. Bye now. So we saw our invite go to the channel to big guy, to local, to North America, to world, to internal, where the internal had the instructions to send the call back out to the SIP module, or maybe I should have said go back up to here, which is represented in the configuration. We now have channel 2002 aware of a call that's going outbound. So we need an IP address of this guy that we're going to contact, and we see host equals dynamic. So as long as 2002 has registered, then channel 2002 knows how to send the invite, and we have a phone ringing. Now the phone will return with a 100 and a 180 and a 200, which will be mapped through the Asterisk proprietary call processing back to 2001. Ultimately, the call connects at the 200 and ACK. So let's say we are at this point where 2001 is now speaking to 2002. The possible media path could be through the real-time codec translator, or if you get fancy and you turn the direct media on after a pair of re-invites, whatever the heck that is, right? That's something that we cover in a separate class, our SIP class, which we're very proud of. But without getting into the details, it's possible to run RTP directly between the two phones, completely freeing up any resources of Asterisk. So the voice going right between the two phones. But the call control remains in Asterisk. Let's make the call control passing through Asterisk like this, where here's the intelligence that's processing the call. And the media, I'll show that as red, which is going directly between the two phones. So what we have is feature control. We have this wonderful feature capability because the call processing is actually being maintained inside of Asterisk. Because of this, Asterisk is actually known as a back-to-back user agent. A user agent, as opposed to a SIP proxy, a user agent is a device that can originate or terminate SIP traffic. Where a proxy passes it through, a UA has to be smart enough to originate and terminate SIP traffic. So it'll send SIP requests and respond with a SIP response, some number code like a 100, 180, 200, or so on. A SIP channel, that's a UA as well. It is not a proxy function, it's a UA, which makes the SIP phone and the Asterisk channel peers. That's UA to UA. There's no proxy in this picture. Now, we will relay through some proprietary Asterisk stuff back to another UA. That's what this context 2002 is, to the called party 2002 phone. So if you count up the UAs in this particular case, you're going to see there's 1, 2, 3, 4 of them, where a couple things are actually getting it right here. First of all, the signaling arrangement between 2001 and the Asterisk UA is strictly between those two. When we map through the proprietary Asterisk call control to another SIP dialog operating between 2002 and the channel 2002, I should really show this as a different color, because as far as 2001 being paired up with its channel module and 2002 being paired up with its channel module, these phones would actually, if we would be looking at this traffic using Wireshark or something, we would see two separate calls. This does a number of things. It maintains security, it maintains call control, and feature activation, since 2001 and its relationship with the channel and 2002 and its relationship with the channel are completely separated by a whole lot of intelligence inside Asterisk to tie the two together. This last diagram simply shows the mapping of the call from our step 4 to our step 5, which I've already discussed. When the proprietary message comes to the SIP channel saying I've got a call for channel ID 2002, the host equals dynamic would map the SIP invite to the called party. It's important for you to realize that while phones may be understood to have phone numbers by the customer, if you're the one configuring Asterisk, do not think that you must actually name the channel a phone number. As long as the channel ID matches whatever the user ID of the phone is, we make a phone number appear using the dial plan. And I'd like you to see that right now. Suppose this particular phone, which we would tell a subscriber is 2001, and that we don't really tell them that we're actually going to use the MAC address of the phone as the user ID. In the configuration of the phone to emulate this for you, let's suppose that in the user ID I did not put the phone number, but instead I typed in the MAC address. Now remember, whatever you put here, you must match in sip.conf. So we would also type in the MAC address as the user ID here as well. Now that makes these two match. Of course, we make the passwords match, as I explained earlier. But how would I get a call to go to this MAC address, which is not even a phone number? Well, the same way you would any other way in Asterisk, and that would be to use the dial plan. So for instance, suppose that 2002 were to dial 2001. If that would be the case, when the dial digits 2001 entered into the dial plan and eventually came to the internal, we would see that if dial digits 2001 matched, then we would dial the SIP channel and this specific channel ID, which would cause a proprietary message to be sent back up to the SIP channel, which would send a SIP invite to this particular user ID. So this would say, hey, user ID 00CA9902AA is receiving a call. The phone would ring and the user really wouldn't know any difference. As far as they're concerned, they just answered 2001, which is what the 2002 guy just dialed. As a review, let's take a look at how all of this worked. In our step 1, we said that phone number 2001, not using the MAC address, but make the user ID actually match the dialed number of the phone. So we say the user ID 2001 is going to match the channel ID in the SIP channel config. In the SIP channel configuration, we see that we enter 2001, that is the channel, where we'd type in the IP or the password, and of course we say host equals dynamic because we're going to have 2001 register. That will dynamically supply this particular channel with the IP address of the phone in case we ever want to send a call out to the phone. Notice that on inbound calls to a SIP channel, the context will steer any inbound traffic to this channel to the context big guy, where the context big guy includes a lot of other contexts that may process, where we see local, North America, international, actually I think I called that world up above. And then in internal, we would actually see the match where 2002 says dial 2002, which would cause a proprietary message to be sent back to the SIP channel, where the SIP channel 2002 knows that the host is dynamic. So because phone number 2002 would have registered earlier, the IP address of the phone would be known because of that registration, and the SIP invite sent to the called party 2002, and the phone would begin ringing. There you have it, the overall call flow from the originating party to a SIP channel through the contexts back to the SIP channel module to the appropriate channel ID, which begins the phone ringing. Once you've mastered this, the next steps, I assure you, will be much easier. The first step is always the most difficult. I'll see you in the next video. Bye now.